Inequalities and linear programming. Graphs of inequalities. Additional maths inequalities with two variables. Now up till now we've had inequalities with a single variable, and it was possible to represent the solution as a part of a line. If on the other hand we have an inequality which involves two variables, such as x plus y is less than or equal to 5, then the inequality is represented by a shaded region of a graph rather than just a line. Now in this case, the border of the region is the line x plus y equals 5, and we need to shade one side of this line or the other. Now we usually shade out the region we do not want, so that we can clearly see all the detail in the region we do want. However, sometimes people shade in the region they do want, and it's very important to state which option you have chosen. In this example, we draw the graph of x plus y equals 5. To do that, we can say, if x equals 0, then y equals 5. If y equals 0, then x equals 5. So having plotted the points 0, 5 and 5, 0, we can draw the line. Then we can shade one side. In a minute we'll discuss how to decide which side to shade. However, in this case, the unshaded region in the diagram represents x plus y is less than or equal to 5. There is an important convention. If the inequality uses less than or equal, or greater than or equal, then the boundary line is drawn as a continuous line. If, on the other hand, the inequality uses less than or greater than without the equal option, then the boundary line is drawn as a broken or dashed line. So, if we take an example, on a graph, show as an unshaded region the inequality y is greater than x plus 1. Well, the first thing we have to do is draw the graph of y equals x plus 1. To do this, we can say if x is 0, then y is 1. We can mark that point. If y is 0, then x equals minus 1, and mark that point. We can draw a line through those 2 points, but we draw it as a dashed line because there's no equals in the original inequality. And then we have to shade one side or the other. Now in this case, the unshaded region is the region we want. So, to summarize drawing the graph of an inequality, the first thing we do is, given an inequality, first change it to an equation by changing the inequality sign to an equal sign. Next, draw a graph of the equation, but draw a broken line if the inequality is a greater than or less than sign. Finally, decide which side to shade. To do this, we must first decide, is the required side, or the viable side, to be shaded, or is the other side to be shaded out? State clearly which option applies. If it's not obvious which is the viable side, select a point not on the line. Then substitute the coordinates in the original inequality and see if the result is true. Let's look at a couple of examples. Example 1. Draw the graph of x is less than 3. Shade out the unwanted region. To do this, draw the graph of x equals 3. Now this is a vertical line passing down through 3 on the x-axis. But draw it as a broken line because the inequality is x is less than 3. There's no equals there. Now we must shade out the region x is greater than 3, so that means we shade out the region to the right of the line. In example 2, we've got to draw the graph of y minus 2x is greater or equal to 3. and we want to shade the unwanted region. Now to do this, we draw the graph of the equation y minus 2x equals 3, and we use a solid line because the inequality is greater than or equal to. Now to do this, it's probably best to draw out a table of x and y, choose some values of x, minus 2, 0 and 2 for example, and then work out the values of y. Now if x is minus 2, we have y minus 2 times minus 2 equals 3, so y plus 4 equals 3, subtracting 4, y equals minus 1. If x is 0, then y minus 0 equals 3, so y is 3, and if x is 2, y minus 4 equals 3, so y equals 7. We plot those points and join with a solid line, and then we have to decide which side to shade. Well, let's choose a point not on the line, say 0, 0 for example, and substitute 0 into y and 0 into x, and we get 0 minus 0 is greater or equal to 3. Now that's obviously false. 0 is not greater than 3, and therefore 0, 0 is on the side which needs to be shaded. So we shade the right-hand side, and that's our solution. Example 3. Illustrate the region that satisfies the following inequalities. X is greater or equal to 0, y is greater than 0, 2x plus y is less than or equal to 10, and y is greater than x minus 2. To do this, we're going to draw the unshaded region as the viable region. Now consider x is greater or equal to 0. We're going to draw the graph of x equals 0 and use a solid line as the inequality is greater than or equal to. This is just the y-axis, and we shade out the region for values of x below 0. For y is greater than 0, we draw the graph of y equals 0, but use a broken line as the inequality is greater than without an equals. Now that's actually the x-axis. We're going to shade out the region below the x-axis, that is where y is below 0. Now for the inequality 2x plus y is less than or equal to 10, draw the graph of 2x plus y equals 10 and use a solid line because we have greater or equal as the inequality. To do this, let's draw out a table, x and y, and choose values of x, let's say 0, 2 and 5. Now if x is 0, y equals 10. If x equals 2, we have 4 plus y equals 10, so y equals 6. And if x is 5, we have 10 plus y equals 10, so y is 0. Plot those points and draw a straight line passing through them. Now we have to decide which side to shade. So if we choose a point not on the line, let's say x is 0 and y is 0, and we substitute those numbers back into the original inequality. So 2 times 0 plus 0 is less than or equal to 10. 0 is less than or equal to 10. That's true. So we don't want to shade the side with 0, 0. We want to shade the opposite side. So we shade the side not including the origin. Now for the inequality y is greater than x minus 2, we draw the graph of y equals x minus 2 and use a broken or dashed line. That's because there's no equals in the inequality. To do this again, let's draw out a table for x and y, choose some values of x, let's say 2, 3 and 5. Now, if x is 2, then y is 2 minus 2, which is 0. If x is 3, then y is equal to 3 minus 2, which is 1. And if x is 5, y equals 5 minus 2, which is 3. We can plot those points and join them up with a line. However, we used a dashed line in this case because the original inequality was only greater than, not equal to. Now, to find out which side to shade, we choose a point that's not on the line. Let's choose x equals 1 and y equals 1. Now, if we substitute them in the inequality, we get 1 is greater than 1 minus 2. In other words, 1 is greater than minus 1. Now, that's true. So we want to shade the area that does not include the point 1, 1. So that is the area under the line. And that's our solution. The unshaded region represents the 4 inequalities.